Dear students, today we are going to see the k nearest neighbors. Last class we have seen about the regression and both the thing it comes under the classification in machine learning. So this k nearest neighbor mainly we are going to find the original data and we are going to find the Euclidean distance between it and finding out the nearest neighbors. From the name itself you can find out which is the nearest neighbors and we are going to find the features. So first what we are going to do is, first we are going to import all the things what it is required. Okay, so first NumPy, that is numerical Python and matplotlib for visualizing the data and then pandas for data frame. So as you know, when you are just read the CSV file, everything which will be stored in the data format. So then we are going to use this data set for accessing the model. So mainly in KNN, as we discussed, we are going to just dividing this data set itself into the training and test data. Okay, so how to do that and how we are going to find the performance, all these things we are going to see in this K nearest neighbor. And before doing all these things, we have to go for pre-processing also. So how to do the pre-processing and how to split the test and training data, and then how we can do okay the confusion matrix, and then finally how to find the accuracy. All these things we will see one after another using the code, right? Okay, so this is the social network ads CSV file. You can see in which you can see age and you can see estimated salary and then purchase. So this purchase you can see like a categorical data. So you can see based upon the age and the estimated salary, you can find the e-commerce whether that person can purchase the item or not. So that only we are seeing in the data set. If it is purchased means we will see it is one, and if it is not purchased means it will be zero, right? So it is a categorical data, right? Okay. So after doing this, what we are actually doing is finding the shape of it. Okay, so finding the shape of it. So you can see the shape, you can see the number of records. Okay, so total number of rows, and you can see three. That is the columns. That is age, estimated salary, and purchase. Whenever we give shape, we will find out the number of rows and column. Why we are doing it means after cleaning, if you are finding out the same rows and columns means it is already cleaned one. Okay, to get that knowledge, we should know how many rows and columns it is already there in the original data set. After doing it, we are just giving the correlation. So as you know, correlation means COR or function name. So that is between the different columns, we are going to find the correlation. So when you see here, age, estimated salary and purchase, age, estimated salary and purchase, these are the three columns, right? So between the column, how the relationship is. So that we are finding the correlation. So when we are seeing that between the age and age, it will be 1. Between estimated salary and estimated salary, it will be 1. Between purchase and purchase, it will be 1. So we can see the maximum value of correlation is 1. And from zero point 0.8 to 1 means it is a strong correlation. And if it is 0 to zero point 0.8 means we can say it is a weak correlation. Mostly you can see it is a full correlation. One is there and the all other thing is only weak correlation between the different columns. So just to know the correlation between the rows, we are just giving this particular function name, right? And then as I told you, we have to clean the data before we are going for any prediction or anything else. Okay, to do first we are going to find out any null values. This is the first type of pre-processing we are doing, removing all the null values and finding the shape. We are getting the same number of rows and columns. That means what? There is no null value which is present in this data set. It is a completely pre-processed one only. Okay. And the next one is we are just how to extract only the dependent variable. So we can see from this data set which is the dependent one, purchased only the dependent one. We can see age and estimated salary. Based upon that, we are getting the result as purchased or not purchased. So we can say this is dependent and all the other columns are non-independent. Okay. So these independent columns we can take it as like X variable, and the dependent variable we can take it as Y variable. So if we want to extract only the dependent variable, that is Y variable, how we have to do? We have to give without colon. If we are giving just colon comma -1 means it will extract only the dependent, okay, variable, that is Y variable. See, for example, if we are going for with colon -1 means excluding the Y variable, excluding the dependent, it will take all the independent variable, all the X variable we are extracting here. Okay, so that is how we have to give the statement. After this, if we want to split the data set, so we have to give the test size as 0.25. If you are giving 0.25 as a test size means the training size will be 0.75. If you are giving 0.30 means the training size will be 0.3. Okay, so that is 70. Got my point? So that is how it is going to split it. What is the use of this training set? Mainly training set we are going to use to train the model using the subset of this data set, that is taking 75%. What about the test set? Mainly we are using the test set to evaluate the performance of the model. So the remaining 25% we have, right? That is the subset we are taking to mainly evaluate the model performance. Okay, so that's why we are splitting the test and train. One thing we have to train the model. On the other hand, we have to check the performance. So for that reason only, we are splitting the completed data set into testing and training. Got it? So after doing it, just we are printing the X train, Y train, X test, and Y test. So whenever we are giving the input as X train means what will be the output? Y train. So what whenever we are giving the input as X test means what will be the outcome of it? That is Y test. Okay. So Y train, that can be either 1 or 0. Okay. So Y train always it gives the categorical result, can be either 1 or 0, either purchased or not purchased. Similarly, Y test also it is going to give the result as 1 or 0, that is purchased or not purchased. Got my point? Okay. So that is how we are going to take. Okay. So taking 75% means in which all the X variable of 75% we are taking. Okay. And then we are getting the outcome as purchased or not purchased. Similarly, for X test, we are getting the Y test as the result, right? Okay, so after splitting this, we are going for what we have to go for again pre-processing. Okay, so how to do that? First pre-processing for cleaning the data. Okay, that is finding the any not null which is present here. But for this pre-processing, that is the second pre-processing, what we are going to do is we are using this standard scaler. This is mainly we are checking the property of the data set. So there should be some age limit, right? When a person working as an employee, he should be like some 19 to 60, some age limit we can give it. Okay, and the estimated salary also it should be like okay 19 years old means it can go for 20,000 salary or something. Got it? He cannot go like 2 lakh 3 lakh in 19 years itself. So there should be some limit in estimated salary and age. If any value which is abnormal, that also we have to okay, using some statistic, we have to using by mean, median, mode, in which we have to okay give the uh, correct fit value. Okay, so for that reason only we are using this feature extraction, that is standard scaler. We are using the standard scaler. Okay, for this pre-processing. Okay, so what is this actually? To get the normal range. Okay, for the different columns. For that reason only we are actually doing this feature extraction. That's why we are importing this standard scaler also. So now we have to fit this standard scaler to X-train and X-test. Got it? X-train means 75% of all the independent variable. X-test means remaining 25% of the X variable. So for both the thing we have to just to fit this standard scaler into it. Okay, and then we are printing it. Okay, when we are printing the X train and X test, we can see the range. Okay, so we can see the range, that is feature extraction. Okay, so that's why every time they will ask you what feature extraction we are used. Okay, what method you are used to for pre-processing. Got it? Otherwise, you will get the wrong answer, right? So that we have to be very careful in it. So after doing all this pre-processing and splitting the test and the training data, now we are going for training the KNN model, okay, on the training set. So here, as I told you, now we got the very clear feature extracted information. So now we are going to find the nearest neighbor. For how many nearest neighbor we are going to do? For 5 nearest neighbor, and the metric is Euclidean and p equal to 2. If you give p equal to 1 means it is Manhattan distance. Okay, so when you see the theory, there are two kinds of distance we can use in KNN. One is Manhattan, another one is Euclidean. Euclidean is p equal to 2. Okay, between the original data and the predicted data, we are finding the difference. And the minimal difference, we are taking it as like a nearest neighbor. Okay, so 5 nearest neighbor, we are taking it out. Okay, so fit between the X train and Y train. Got it? So that is the fit we are giving it out. Whenever we are giving this, will be coming automatically. Okay, that is nearest neighbor classifiers. Okay, and then we are predicting a new result. So, for example, what is this actually predicting a new result? So, sometimes if you are just giving predicting a new result in which sometimes unseen data, if you are giving an unseen data gives us input. This combination of age 30 and salary 87,000. Okay, so it will give only the purchased as 0 because it is an abnormal combination of age and estimated salary that have been never in the training sample. Got my point? So when we give like this, it is going to give the result as 0. That is not purchased only. Got it? That's why we are getting 0. That is not purchased. Got it? After that, we are just predicting the result now. For that, we are going to concatenate. Okay. What we are actually concatenating? We are concatenating the Y pred and the Y test. Okay, so Y test and Y pred. Okay, so we are going to concatenate it. Okay, so why we are actually concatenating to compare side by side in printing. Okay, when you give concatenation, we are just side by side, we are printing the Y pred and Y test. Got my point? So this is how we are going to find out. Whenever we find the confusion matrix, that is the time we have to take one as the actual value and the another one as the predicted value. So, for example, when you are going for a training sample and all, we are given it as, and then if you find the thing, okay, so one will be taking it as like a actual value. Another one we have to take it as a predicted value. If we are giving one, the prediction also should be the same one. Then only it is correct, right? So if the actual value is one and the predicted is 0 means, then it is a contradiction result. So we have to find out, okay, the confusion matrix whenever any contradiction occurs or not. So there are 4 combination we can say. For example, if both are 1, okay, we can say that is true positive. Sometimes if both are 0, then we can say it is true negative. Okay, because 0 is always negative, not purchased, right? 1 means it is purchased, it is positive. So we can say both are correct means, okay, if the actual is 1 and the predicted also 1 means we can say that it is correctly predicted. Got it? So we can say it is true. And then we can say it is okay, positive or negative. So that is the time we can say 1 means it is positive. 0 means we can say it is negative. Got my point? So both are 0 means it is negative only, but actual and predicted is correct. So we can say it is true. Got my point? So we should not confuse with the true and positive. Okay, so that's why we are getting the putting it in okay side by side. That is Y pred and Y test. Okay, so that is how the different combination we are getting. And finally, when we are just asked to, okay, when we are asked to make the confusion matrix, So that is the time we are just giving this confusion matrix and accuracy score. That alone we are going to do between the y test and the y pred. So test here, it is an actual data, and y pred is the predicted one. Okay, so if you are giving the input, okay, so that is the time if you are just asking it to print the confusion matrix, that is CM, so you are getting the value like this 64. So that means what? It is actually in the matrix format. Okay, so 64 means, see, for example, the first row in the y-axis can be considered as 1, and the next is 0, and then the first column as 1, and then the second column as 0. When you are giving like this means what? Actually means 1 if it is the actual value, and the predicted value also 1. So that means what? We can say that both are 1 means we can say this is true positive. So we can say 64 is true positive. And as I told you, the first row is 1 and the second column is 0. Okay, so 1 0. Okay, 1 0 means the actual is 1 and the predicted is 0. Got my point? So such situation, what it is called false negative, because it is not correctly predicted. So it is false. And what it is predicted, negative value it is predicted. As I told you, negative value means it is not purchased, 0. So we can say 4. Okay, that is 4 is false negative. Got my point? Similarly, 29 means what? Here also 0 and here also 0. So correctly predicted, so we can say it is true, but 0. 0 means what? It is negative. So we can say true negative is 29. Similarly, 3 means what? We can say that, okay, this is 0, okay, actual is 0, okay, and then predicted is 1. Okay, so 0, 1 means we can say it is wrongly predicted, so we can say false, but we can say 1. Okay, predicted is 1, so we can say 3 is false positive. Got my point? So this is how we are just giving the confusion matrix. We have seen so many y pred and y test. We have asked to print it side by side, right? So now we have to find out from this combination how many things are true positive and how many things are true negative and how many things are false negative and how many things are false positive. Got my point? This is how I asked to print in the matrix form. So after doing it, I have to find out the accuracy score. How to find the accuracy score? We can just find out true positive plus true negative divided by all the four. When you see the theory, you can know that is the formula for accuracy. Okay, so how to find the accuracy? True positive, that is 64, and then we can say true negative as 29. So 64 plus 29 divided by all the four. 64 plus 4 plus 3 plus 29, I'm getting 0.93. Okay, so I can tell 93% accuracy. Okay, so I hope you understood from this clearly about the KNN. Okay, finding the five nearest neighbor using the Euclidean distance, and also you have known how to find the confusion matrix in the combination of y pred and y test. That is the from the testing and the training. Okay, so combination we have found out, okay, the confusion matrix and the accuracy. So one side we have calculated the performance also, right, using the KNN, right? So I hope you understood very clearly about it. Okay, so if you have any doubt, post to me so that I can clear your doubts in KNN. Okay, in the next video we will see with some other new topic. All the best. Thank you.